Okay, guys, take a look at this disaster. I thought I had a fixture made up to flow intake manifolds, and I can't for the life of me remember where I put it or how I did it. So, I was feeling crappy today, and I decided to do some work on the David Vizard Brezezinski copy intake. Actually, I did more than one day's worth of work on it. I put quite a bit of work onto it. And anytime I see clamps on a flow bench, I'm like, that's kind of not good. Well, I tried to do this a couple different ways, and the only way that I got any decent readings out of it was to stuff the runners that I wasn't using with an old foam pillow, and you really got to stuff them because you got to have the bench set up to flow as much as that runner will flow. Okay, so you have to pressurize the intake, right? Exhaust style, right? Exhaust. Range 4, which is 300. It'll do 335 CFM that way, which is more than enough for a single port. Right? We know we're not getting that much out of each intake port. Not happening. Okay, I'm going to try to show you each runner. You can see the welded in aluminum all the way up front. You can see how much straighter the runner is now than it used to be. It was neck down quite a bit towards the exit. The 1204 is not perfect, but you got to realize it was done, I can't tell you how many years ago, and it wasn't perfect then. All right? So that's number 1, which is a lower H. That flowed 243.4 CFM. Okay, number 3. You can see all the way in there where the hole saw cut out. You can see the aluminum that was welded in. That had a complete reshape. Okay, from top to bottom, quite a bit. I took a ton of metal out of this in recent times. I had a couple of days when I just felt like some grinding. And I don't know, I guess I could do a little bit of intake manifold theory while we're looking at this mess. Okay, I grabbed my Victor Jr. tall from early 90s, and you can see how it should be done right here. Notice how tall this runner is, right? Tall, and then it tapers down to the port side, right? Does it come in a perfect angle? No, Victor Juniors aren't perfect, but it's an older design. But still, way more efficient than a double H dual plane, right? So what do you want to do on a dual plane? It would be nice if you could put some kind of a taper into it. Now you got to remember, this was a factory dual plane, aluminum dual plane, quadrajet, EGR no less. Really bad, probably one of the worst. Why did I pick this at the time? That's a good question. I don't know. But at the bottom of that runner near the hole saw, that's been widened quite a bit to give the air more of a chance to get around that corner. You can see where the divider is. Really a sharp turn right there. Did what you could. Did what I could at that point. Okay, number 3 flows 280 CFM. Okay, here's number 5. You can see into it pretty decent. You can see the divider that was welded in. You can see the hole saw that was drilled in it. You can see, for some reason, it's got a bolt in it. I must have had a vacuum leak, and I put a bolt in it to keep the vacuum leak from going away. I did run this manifold for a while. It made good power. Nothing compared to what it would make now after I did much more work to it, 20 plus years later, however many years it's been, I don't know. It's been a long time. Okay, that was number 5 runner, and that flowed 278. And this is runner number 7. You can see the divider welded in. It is a tight turn there, right? So I had to expand it as much as I could. You can see on the left side of that port is expanded quite a bit to give the air some room to make that turn. And the right wall was a crummy shape as well, and it necked down towards the opening of the roof. So that's all been widened and straightened. That flows 257.6. Okay, this is port number 2. Same thing. You can see the aluminum that was welded in. You can see the hole saw. You can see how much it was widened so the air has a chance to make it around that turn. Right? That port flowed 255.9 CFM. Okay, this is port number 4. Lower H's are tough. That floor is completely flat. There's no metal there at all. Right? Obviously, this manifold's upside down, so you guys are looking at the roof of the manifold. Okay, you can see the aluminum welded in. You can see how much it was widened. You make the inside curve the best you can for what you have. Not the easiest manifolds in the world to port. Actually, it was probably one of the more difficult manifolds to port. Okay, so that was port 4. Port 4 flows 242 CFM. Okay, this is port 6. Same thing. You can see the divider welded in. You can see how much it was widened, how much it was raised, and how it was widened towards the exit. It was much, much narrower stock. That one flowed 266.6. Okay, and here's port number 8. Port number 8 is notoriously lean on a small block Chevy. Maybe you guys can tell me why it is that way. But you can see it's been widened considerably. You can see the aluminum that was welded in. It flows 274.7. So, here's a quickie map of it. The dots represent where the plenum's attached to the H's, right? I actually may have them upside down. I don't know. Doesn't really matter. But it is interesting to see how close, right? 266.6, 257.6, right? 242, 243. Think about that for a minute, right, guys? That's really interesting. So, the flow we've got between those 4, and that's a lower H, are pretty darn even. We would expect the lower H to flow less than the upper H because this, like the Edelbrock Performer has bigger runners on the upper H than the lower H. So the lower H has got a completely flat floor, so it enters the intake port at a terrible angle, and it doesn't have much roof height coming into the port. So it's not going to be nearly as efficient. Let's take a look at the same thing. The upper H, 274, 278, 280, and one is 255, which is down quite a bit. But the other ones are right in the same neighborhood. Now, why would number 2 be that far out? It's probably that turn. It's probably that turn down there. It's a little tough to make that. Come on, there you go. So that, I probably could put a little more work into that. Bring that wall over a little bit. I might do that. This was my first flow on this intake in a long time, so. Okay, let's go over the upper and lower H's and see what you got. Okay, huge amount of work in the plenum. The plenum is massive. Now somebody's going to say, Charlie, why is it important to have a huge plenum? Well, it's a reserve of air for the engine, right? We rarely talk about cylinder head demand or engine air demand, anything like that. We never talk about it. Actually, it's super important. And the more air and fuel you can hold in the plenum, the quicker that can change. Plus, it makes a big difference. The air going from the carburetor into a big plenum, that change in pressure makes the fuel instantly evaporate. That's super important. Okay? Every curve has been changed, right? This used to be 4 holes. 4 holes, and the divider used to go to the top. Well, this has had, I believe it's a 1-inch spacer welded to the top. 1, to give the plenum more volume. 2, so we can share barrels. Why? Because it's a sleeper intake. Okay? Okay, lower H. Plenum is absolutely massive. Completely gutted out. Everything has been changed as far as shape. All right? People are going to ask what that iron boss is. Well, that's where they drilled that plenum for the EGR. Okay? At the factory. And they put a bolt. They put a boss in there. Threaded it. Okay, you can see the radius from the plenum into the runners. You can see where it was welded. You can see where it was all blended together and expanded. Okay, the other side of the lower H, right? Huge plenum. I'm not really thrilled about how they shaped the plenum. That double bump there doesn't really do anything. Okay, a quick look inside the Victor Junior plenum. Right, now this isn't just a regular Victor Junior, this is a Victor Junior tall. Right, it came from the factory with a 1-inch spacer added on. And I would never do that again because it's just terrible to port it. Take a look at how deep that plenum is versus this plenum. Okay, about a 1/2 inch difference from the lower H to this massive monster that's designed for 8,500 RPM, I believe. You guys can correct me on that, but I believe a Victor Junior is good for about 8,500. Okay, so some of the manifold theory we can go over again, right? As far as your plenum is concerned, bigger is usually better. You're going for horsepower, okay? As far as a street manifold, this manifold was fine. I actually used this in a pickup for a while, and it was no problem on a 355. Was it as crisp as it would have been if it had a full divider? No. You lose foot-pounds of torque with the divider cut down like that. That's one of the reasons I'm not a fan of the Edelbrock Performer air gap, right? But this manifold was designed like this. This is actually the Vizard modification. In his book, he's got the spacer welded onto the top of the manifold. As far as flow to each cylinder, I've seen way worse than this. Way, way worse. We could do a percentage on it. I'm not able to do it off the top of my head because I'm still not 100%. I'm not really feeling great still. But overall, I'm pretty proud of this manifold. This thing will definitely cause some trouble for somebody along the way. Alright, I might as well give you guys a look at the floors as well. Okay, this is cylinder number 2. Okay, cylinder number 4. Cylinder number 6. Obviously, I didn't quite finish cylinder number 6. But that's okay. Cylinder number 6 tested at 266.6 CFM. I'm not going to worry about that, right? And cylinder number 8. Okay, you can see the floor radius is completely changed. Like, the radius going into the plenum is completely different. I didn't think of it at the time, but I should have flowed this with the foam bolted to the bench, well, clamped to the bench before and after. I should have done that. Okay, the floor of number 1. Floor of number 3. You can see that some of these ports were way more challenging than others. Which is, you know, it's kind of part of the fun of porting out an intake manifold. Fun, or maybe not fun, depending upon your point of view. Okay, port 5. And port 7. Okay. You guys have to remember, it's a stock quadrajet intake. There's only so much you can do with it. I personally know I will never do another manifold like this ever. The amount of work was just insane. The amount of welding was insane. Yeah, my welding looks like crap. Well, guess what? It was a long time ago. And my MIG welder was not really great with aluminum. Nowadays I would TIG it, but I don't have my own TIG. Okay, just a quick recap. Right? The plenum comes in at an angle, has a divider welded in. These have been expanded as much as possible to give more area before it starts to constrict and speed the airflow up towards the entrance, right? Think of the taper on a Victor Junior. Okay? If you can do that on a sleeper style intake like this, it'll help a huge amount. Right? Big plenum, the divider cut down so we can share barrels on the carburetor. A big carburetor doesn't really hurt on a manifold like this too. Due to some restrictive runners, bigger carburetor would help. Something like this, an 800 Rochester off of something like a Cadillac or a 454, looks exactly like any other quadrajet unless you know what you're looking for. And then of course, if you know how to hot rod a quadrajet, you can get excellent performance out of one. Okay, so big plenum, radius, everything is radius. Now, if you go through the engineering books, they'll be like, these were originally designed with a sharp edge at the bottom of the barrels to shear the fuel. Yeah, we're not doing that. We need airflow. The really rough texture will help keep the fuel in suspension. Notice I did not machine those trenches out on the bottom. What are the trenches for? They're to hold liquid fuel. If liquid fuel falls out of suspension and hits the floor, it's supposed to be warmed up by your exhaust crossover and then boiled into the airstream. Okay? You do not machine them out. You leave them. Your carburetor shouldn't be puddling fuel anyway, right? But on a cold day, you may get some of that. In Florida, I wouldn't have to worry about it. All right, guys. Sorry, this is 22 minutes on this intake, but the last video I did of this intake was extremely popular. So I hope you guys got a little something out of it. I may have to test some other intakes this exact way, but I'm willing to bet this really isn't that bad. In fact, it's quite good. With the amount of effort that went into it, it should be good. Thanks a lot, guys.